Testing, 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 testing. Continuing right along, as you can see, I'm going from Rhino syntax through to just Rhino geometry, if I can swing it. So let's take that out and at least aspire to what we're trying to do, which is deal solely in Rhino common. So pop that up there, and you can see I have a Python script, which is down here. It was borrowed by in Rhino common, the atlv.org website. Great examples. This one was actually referred to as lines between closest division points, which is not something you wouldn't have tried in Grasshopper, probably watching tutorials. And you can see that I've imported Rhino geometry as RG. I've made 2 blank lists, and so I've had to have those extracted here. And then I've set curves, which is coming in as a list. You can tell by the wire on here. And of course, you have to set your type hint. You have to set your access to lists, not item, and you're not dealing in trees yet. We will get there. And then your type hint is going to be a curve, obviously, because you're bringing in curves. And your divider is set to, I believe, an integer. Let me just check that. Type hint integer, perfect. And I'm allowed to slide that through, and then you get your outputs, your A/B lists. And at times, you should see in creating blank lists, obviously in the section of code, there will be a pending of that list. You're pending it with a point in this case and pending it with a line in this case. You're starting to read your code almost like by tabs. Like that's slowly what I would say I visualized and started to adjust my eyes to. Like, is this going to take care of all that? Is this going to take care of all that? Is this for loop going to take care of all that? Is this for loop going to take care of all that? And you're dealing with conditionals, and you're dealing with also the elif statements and if statements, which are kind of nice. So let's just try and follow what's happening. Now, I inputted several curves. And if I just take a look at this and go to visibility and bring in what I've done, and I'll take this, well, I didn't want to do that because now my curves are tucked in there. I've actually internalized my curves, so we could get rid of all this and go into a window like shaded and see what we're working on fully. I've actually, if I externalize this data, extract parameter, I should be able to see, oh no, I got rid of everything I needed. So yeah, the curves are there. I better just leave them. But I made a set of curves, and then I just lofted them up and shrank them from top view. And so there actually are several objects here. I guess I could select lines. So you just want to select curves. And in doing so, we'd have those curves. I'll put those in hiding, and we'll get rid of all this other stuff. So we've got our curves on there, and we have our. We can take this out now. We can move away from just seeing those. We can take a look at the curves that I imported. So I did import those, and usually I don't do a lot of stuff in Rhino, but I thought I'd be a little playful. And I was playing with that. I was like, okay, should I group these two, and then I can just pair them, or should I just run them all through so this becomes interconnected? There's a little bit of problem with my script that this connects up to here and these connect up to here, but I don't mind it for structural. I kind of wish I had more lines connecting this to that. So this technically could be fabricated as a canopy. That would not be much support, and architecturally and engineering-wise, they'd just be like, Mike, stop living the life of a pure mathematician on this stuff. You've got to think to apply it at some stage in your life. Anyway, back in the script. I took those curves, I started with blanks, and we're going through 4 curves in curves. So it's basically counting each one of these curves, and it's iterating through them, and it's kind of nice to see what's happening. Say, as long as this curve is not that curve, so that's cool, and actually maybe I should stay up here. Take that curve, divide it, and add 1 to it, which you have to do with kind of dealing with just a little bit of math in there. And then I is another nested loop within there of a range, and dividing, keep in mind that that's an integer value that you can change. And in changing, of course, that's going to make for different geometries. And I've got it slowed down because of a pipe and a cylinder right now. So you've got to kind of keep in mind of what's happening as I change that iteration, change the amount of pipes that are between those. So should have showed you that off the bat. So think about your code as it's happening. You're appending your list. And then decide your other variables as they go in. This is interesting that I started a minimum distance is equal to -1 to initialize it to -1, not to 0. So that's a new thing for me. And then as long as curve 1 is not curve 2, you can do another nested loop of J running through the exact same script that you did above, except you're going to take your point and you're going to make a curve point at, which is a Rhino script syntax. Doesn't need either one. Like the point at works with a curve. variable, which is kind of nice, and I didn't have to do any change there. But I did have to get in here and change the RS distance to 0.3D distance 2, which we've done in the last one. And I also had to change my line, add line down to RG at line. So you've got your LF statements, your minimum distances. Chase this math. If it gets so convoluted in here, you're not wrapping your head around minimum distance, maximum distance as variables, what that distance is, how the LF statements work. It's sometimes good to just trust some of this works and borrow some scripting code until you can wrap your head around it and get into the maths. Because when you can get into the maths and get deeper into that, let's import math, and I haven't done this yet, and I'm not even sure what I'm even thinking right now because I'm not thinking yet. Where could I bring in something with number and have fun with a little bit of maths on here? And of course, I'm seeing a lot of points, so that's not going to be something I wrap my head around. But dividing is going to be you could at any point come in here and start to use some maths. And if you don't know what they are, just type in math after that, hit point, and start thinking, okay, do I understand my trig and what I was doing in school? And I can think to how to apply this. And because it's a pretty large form, and these get into some pretty good decimals, I think I'll leave it and I'll think about it. But for this initial stage of just showing the script, basically I'll take that out, and you can think about how this script generates two array of lists, one of which I can set to points and one of which I can set to pipes, and you end up with a little object like this, a little bit of a toy to play with. So fun to see what's happening here and using some things that you maybe haven't yet, like the not conditional, and getting into keeping almost everything away from hard coding. That's what I really like about this one is we've actually been dependent upon geometries that we imported, and then we have to play off of relationships between them outside of saying, okay, this will do exactly this, which is the real value of that. And then making this geometry, I could have gone in Grasshopper and defined it and tried to do it myself from those curves. It's not that. You have to ask yourself, could I have not done that faster in Visual Node Control here? But the best thing is I can just grab these little clusters whenever I need them. I can just grab them as a Python cluster as opposed to taking a scripted Grasshopper and then putting it into a cluster and remembering what it does. Here I could actually put a little note on exactly what that does at the top and just comment it out and maybe call something like that. We could say, okay, it takes input curves, and I'm just not typing for some reason because I must have been on another screen. Yeah, it's taking input curves and pseudocode, and I should be friendlier with this, and it's lines between, I'm just going to use what I have up top, closest division points, and that's coming from the files that were in Rhino script syntax on atlv.org. So I'm not trying to steal credit from this. I'm just trying to show how to learn. You might want to learn Rhino script syntax while you're learning Rhino geometry because you are going to go farther and farther to the left of the Python script if you do that. And that's really my goal, is taking everything that jumbles out of the parameters, pack it into a Python, and then go deeper into the Python to see what's there. I won't waste your time. I'll probably play away after I get off of here with some of those math tools I just imported and see what I can do. But I will hit test, make sure the script's still running. Always close your file. I haven't been doing this, so I've been saving all these files, leaving this open. So when I go in to make the next script, and I heard this is a problem, people forget to close their file. They change one and don't realize that window here is actually tied to a completely other code that you have here open. Like you didn't notice that window was not coming back to this Python node, and you change a script to update it to a past file. So then when you open the other file, you're like, hey, this script doesn't match. This script doesn't match the parameters and what I had outputted from the other one. If that's not making sense, you'll probably experience it yourself, and you'll be frustrated that you have all of these wonderful files like this, and you've messed up some in the process of doing it. But I'm generating them all from kind of the switching from Rhino script to script, and then I'm going in and putting a WS on the end when I do something fancy that they didn't do. And I'm not doing anything really trickier than piping and putting spheres on. And if I really wanted to go fast, I could try some mesh pipes and some mesh spheres. But right now I don't see anything going too slow, so I'm pretty good. And I think my profiler's on. Always check that on your preferences widgets. Go in here. Actually, that's not where you're supposed to go. I think it's display. Canvas widgets. Just make sure you have your profiler on, and I keep everything on to keep track of what I was using. Yeah, but the profiler is really what you want because it'll tell you the speed when things start creeping over top of when you run your script, how long it takes to run it. If I change the script, it's kind of interesting. Like if I just change it and change it back and hit test, I think it does run the script again. But I've been starting to experience that in C#, where it's kind of a hybrid compiler interpreter. It takes longer the first time when you do that, and then it goes faster and faster each time. Anyhow, that's just out there for somebody who's interested in what I'm talking about. And we've got a nice little thing here. Let's put it on visual. Let's do a little bake. Just for fun. Let's group it. And let's throw it back into this nice scene, which will take a little bit of time because I'm doing technical drawings. Always takes me a little longer to load up other shapes. Because of that, this is trying to go to pen and ink. This one's going to technical, which is squeezed aside. This one's going to artistic. And then here I usually send this one over to rendered once I've got it in there because I like the shading. Just like the look of it. If I don't want to see that blue, I can take it off. And if I just want to see red, I think I can just click out and put it on view all. There we go. Anyway, if you also don't like the colors, I'll just throw that in. There's bonus preference tools. You can go in here and grab palette. No, that's not what I want. Why did I all of a sudden forget? Oh my gosh. Sometimes I think too much and I can't do it. All right, I better end it while my mind's kind of in a jumble. But for preferences, palette, widgets, viewport. There it is. Now, if you didn't like that color, you can pull that in and say, okay, when I select things, I want it to be a green, which is kind of horrible. That's why I always prefer the blue, maybe something rich and dark and purple, something that's visible on there. And I can also go out here. And if I didn't have one thing you'll end up doing is if you have a template that you open up each time, which I'm doing for another site, it's going to default. So every time you go into here, you got to change that if you actually want to select a different color of what you have. I like blue and orange, so just a little side note for those that are interested, right-click here and just pull that back to a nice orange as opposed to a red, or you could go towards a green, but that's not going to counter. And a yellow is going to fade away. Well, we'll see if that one works. So when I'm in there, I've got a pretty putrid orangish yellow. Anyway, just a little sidetrack there because I felt like it. Anyhow, I'll keep going with this script. We're at 12 and a half, 13 minutes, and keep developing. Our next script is going to be kind of fun because we're going to draw lines between we're going to do intersections at this point, and we're going to get into, let me just look ahead. It's going to have Rhino script syntax and Rhino geometry, and I have to wonder why people do that, and I guess it's because sometimes it makes more sense or it's more convenient thinking Rhino script syntax or add surface points and things like that. So why is that in use, and why have they not converted Rhino script add surface point over to a Rhino geometry or RG or Rhino common function or node? And I'll try and figure that out while I go. Otherwise, I'll do the best I can to switch over what's in there from Rhino script syntax to Rhino common. I'll get better. The best thing about programming and developing is when you learn something the first time, it's hard to forget it. It's hard to remember how to do it, but it's hard to forget that you learned something about it. So please, if you're into this, jump into it, jump onto the forums, jump onto the private site that I've got open that we're going to start developing this in a 1, 2, 3 ABCs of GhPython for Grasshopper Rhino. Salut!